Imagine traveling through the cosmos at an impossible speed. You fly past galaxies spiraling like pinwheels of light, past glowing clouds where new stars are being born. The universe is a brilliant, crowded place. And then, suddenly, it stops. The river of light dries up. All around you, for as far as you can see in every direction, there is almost nothing. You have arrived in a place we call the Boötes Void. Some call it the Great Nothing. It is a colossal spherical region of space, a hole in the fabric of the cosmos that is almost entirely empty of galaxies. This is not a small gap. It is 330 million light-years across. The existence of such a place is one of the most profound puzzles in our study of the universe. How can a hole this big even exist? To understand a hole, you first have to understand the shape of the thing it's a hole in. The universe, on its largest scales, is not a random scattering of galaxies. It has a magnificent structure, a shape that we call the cosmic web. It is the grandest architecture we have ever discovered. Think of it as a vast, three-dimensional network. It's made of long, brilliant threads of galaxies called filaments. These filaments stretch for hundreds of millions of light-years, connecting to one another at bright, dense intersections. These intersections are where we find superclusters, immense collections of thousands of galaxies, the great cities of our universe. And in between all of these luminous threads and shining knots, there are vast, dark, empty regions. These are the cosmic voids. They are a natural and expected part of the cosmic web. But the Boötes Void is different. It is so much larger than our theories predicted was even possible. It is a void among voids. The story of its discovery is a perfect example of how science works. In 1981, a team of astronomers led by Robert Kirshner was working on a project to map the universe in 3 dimensions. They were pointing their telescopes at a slice of the sky in the direction of the constellation Boötes, the herdsman. They were measuring something called redshift, which tells us how far away a galaxy is. They expected to find galaxies scattered at all different distances, filling their map with points of light. But as they gathered their data, a shocking picture emerged. They found some galaxies nearby, and some very, very far away, but in between, there was a gargantuan gap, a volume of space where there should have been thousands of galaxies, but they counted only a few dozen. They had found nothing, where there should have been everything. Let's try to truly feel the scale of this place. 330 million light-years. The number is so large it feels abstract, but we can measure it against things we know in space. Our own home, the Milky Way galaxy, is a vast island of stars, about 100,000 light-years from one edge to the other. You could take our entire galaxy, with its hundreds of billions of stars, and place it inside the Boötes Void. Then you could place another one next to it. You could continue doing this, lining up 3,300 Milky Way galaxies side by side before you finally stretched across this expanse of emptiness. Or consider this. Our closest major galactic neighbor, the Great Andromeda Galaxy, is about 2.5 million light-years away. That journey, which would take light 2.5 million years to complete, seems immense. Yet, the Boötes Void is more than 130 times wider than the distance separating our galaxy from its nearest large companion. It is an ocean of quiet so profound it challenges our understanding of how the universe itself was built. So, how could such an immense emptiness come to be? The story doesn't begin with an explosion that blasted everything out. It begins with a whisper in the very first moments of time. To understand this whole, we have to go back almost 13.8 billion years to a time just after the Big Bang, when the entire universe was a hot, fantastically dense soup of particles and energy. This primordial soup was almost perfectly smooth, almost the same temperature and density everywhere. But almost is the most important word in cosmology. There were tiny, microscopic variations, ripples from the quantum world itself, called quantum fluctuations. Some spots were infinitesimally, unimaginably slightly denser than others. These weren't holes or clumps yet. They were just the faintest seeds of future structure. These tiny seeds, scattered throughout the infant cosmos, held the blueprint for everything to come. They were the starting points, As the universe expanded and cooled at a furious pace, a silent, invisible force began to take notice of these tiny differences. A grand cosmic construction project was about to begin, and these little fluctuations were the foundation. And the master architect of this project? A substance we cannot see, cannot touch, but whose presence shapes the entire cosmos. It's called dark matter. This mysterious, invisible matter makes up about 85% of all the matter in the universe. It doesn't shine or reflect light, but it has gravity. A lot of it. And its gravity is the sculptor of the universe. Over hundreds of millions of years, the immense gravity of dark matter began to pull on those slightly denser regions. Where there was a tiny bit more matter to start with, dark matter's gravity pulled in more, making it even denser. It was a slow, relentless process of cosmic accretion, a gravitational snowball effect on an unimaginable scale. Matter, both dark and the regular matter we're made of, began to flow from all directions toward these growing cosmic cities. And what happens to the places that matter flows away from? They become empty. The voids, including the great Boötes Void, were not carved out. They are the spaces left behind. As dark matter herded galaxies into the great filaments and clusters of the cosmic web, these vast regions were simply drained of their substance, their galaxies slowly migrating away to join the brighter, more crowded neighborhoods of the universe. There's an even more elegant detail to this story. In the very early hot plasma of the universe, pressure and gravity fought a cosmic tug-of-war. This created gigantic ripples like sound waves that surged through the cosmos. Scientists call this baryon acoustic oscillations. Think of them as the universe's first sound, echoing through space and time. These sound waves pushed regular matter, the baryons, outward in a sphere from the densest points until the universe cooled enough for the waves to freeze in place. This created vast, bubble-like structures throughout the cosmos. The current thinking is that the Boötes Void isn't just one of these empty bubbles, but the result of several of these ancient bubbles merging together, creating a single colossal region of underdensity. But here is the thrilling part. The twist in our cosmic detective story. While this process explains how voids form, our best scientific models, our standard model of cosmology, have a very hard time making a void this big. The physics works, but the scale is all wrong. A hole of 330 million light-years is a staggering statistical anomaly. According to our simulations of the universe's evolution, a void of this magnitude is exceptionally rare. It's so unlikely that its existence makes us pause and wonder. It suggests that perhaps our understanding of the universe's grand structure is not yet complete. The great nothing is not just an empty space. It's a profound scientific question mark hanging in the cosmos. But the universe, as it so often does, held a surprise. After years of peering into that profound darkness, we discovered a stunning secret. The Boötes Void is not completely empty. It is not a perfect, silent nothingness. There is something inside. Patient, deep surveys of the sky began to pick up the faintest glimmers of light from within its borders. Not just one or two, but dozens of them. As of today, we have confirmed the existence of about 60 galaxies inside this great cosmic ocean. 60 lonely islands of light, adrift in a sea of dark that is almost incomprehensibly vast. And here is where the story takes its most bizarre turn. These galaxies are not scattered about randomly, like lost ships on that sea. Instead, they are arranged in a long, thin, almost tube-like shape, a delicate filament of matter stretching right through the heart of the void. It is a structure where, by all rights, no structure should exist. How could this be possible? Our best explanation is a grand story of cosmic survival. The leading theory suggests that the Boötes Void is not one single entity that was born this large. Instead, we believe it formed from the merger of several smaller, pre-existing voids from the early universe. Imagine smaller bubbles of empty space expanding and pressing against one another. As they merged into one superbubble, the galaxies that happened to be caught on the boundaries between them were squeezed and shepherded together. They were swept up and collected along the seams of the merging voids, forming the strange, fragile filament we observe today. These galaxies are not intruders. They are the survivors. And this realization changes how we look at the cosmos itself. That 330 million light-year hole is not a flaw. It is not an absence of the universe. It is the universe. The grand story of existence is written just as much in the vast, quiet voids as it is in the brilliant, clustered galaxies. This emptiness is a form of structure. These voids are the other half of the cosmic web, sculpted by the very same fundamental forces that build everything else. They are a quiet testament to the patient work of gravity pulling matter together and the relentless opposing push of dark energy, the mysterious force that is accelerating the expansion of space itself. The void shows us the rules of reality on the largest scale we can observe. And yet, the story isn't finished. While this theory of merging voids is elegant and powerful, the sheer shocking size of the Boötes Void still challenges our cosmological models. It remains just a little too big, a little too empty, to fit perfectly with what our simulations of the early universe predict. It is a gentle reminder that the cosmos is still full of surprises. It makes you wonder, doesn't it? What other, even larger structures are waiting for us out there in the dark, just beyond the reach of our current telescopes? What new physics, what new understanding of the universe will they reveal to us? The Boötes Void is not just a hole. It is a profound question, hanging in the cosmos, inviting us to look deeper, to learn more, and to never, ever stop being amazed. And so, these great voids, these silent expanses, are not just curiosities. They are fundamental tests of our understanding. They challenge our models of the universe. If our theories are correct, voids of this size should be exceptionally rare, perhaps even unique. Finding more of them, or finding one even larger, could mean we have to rethink the very story of how everything came to be. To answer these questions, we are building new eyes to look deeper into the dark. Missions like the Euclid Space Telescope are designed to create the largest, most accurate 3D map of the universe ever made. They will chart the positions of billions of galaxies, tracing the cosmic web with incredible precision and revealing the shapes and sizes of voids we can currently only guess at. These new maps will allow us to see if the Boötes Void is truly an outlier, or if the universe is filled with more of these colossal structures than we ever imagined. By studying the faint galaxies that do exist within them, we can learn about how structure forms in the most isolated environments imaginable, giving us a clearer picture of the forces that shape the cosmos. And here is a thought that truly stretches the mind. The voids might be the perfect laboratory for studying one of the biggest mysteries of all, dark energy. This is the mysterious force that is causing the expansion of the universe to speed up. In the dense filaments of the cosmic web, gravity and dark energy are in a constant tug-of-war. But inside a void, where matter is scarce, dark energy reigns almost unchallenged. By observing how voids grow and evolve over cosmic time, we might be able to measure the properties of dark energy with a new kind of precision. The emptiness, the nothingness, could hold the key to understanding the ultimate fate of our universe. The story of everything might be written not in the bright lights of galaxies, but in the profound darkness between them. There is another fascinating puzzle connected to these empty regions. When we look at the oldest light in the universe, a faint glow left over from the Big Bang called the cosmic microwave background, we see it is incredibly uniform, but it has tiny temperature variations, including one particularly large and mysterious cold spot. For a time, astronomers wondered if looking through a colossal void could create such a cold spot. The idea was that light from the cosmic microwave background would lose energy as it entered the gravitational well of a supervoid. And because of the accelerating expansion of the universe powered by dark energy, it wouldn't gain all that energy back on its way out. This would make it appear colder to us. It was an elegant theory, linking the biggest structures to the universe's first light. However, while we have found a supervoid in the direction of the cold spot, it doesn't seem to be deep or empty enough to explain the entire effect. The mystery continues. Let's try, for a moment, to truly imagine being inside this place. Imagine your starship crossing the boundary. The rich tapestry of galaxies that fills our night sky would slowly, imperceptibly fade away. For millions upon millions of years of travel, you would look out your window and see almost nothing. Just an endless, deep, profound black, punctuated only by the impossibly distant light of galaxies on the other side. This journey through the void would be a journey through the truest form of cosmic isolation. It is a scale of solitude that redefines the word alone. The sheer, silent emptiness would be a testament to the power of the universe's initial conditions, a physical echo of the tiny quantum fluctuations that grew into the vast structures and the even vaster voids we see today. And in that emptiness, we find a deeper appreciation for our own cosmic home. We are not located in a void. We live in a rich, vibrant filament of galaxies, a thread in the cosmic web. The existence of the Boötes Void, in all its staggering emptiness, makes the fullness of our own galactic neighborhood feel that much more precious, that much more significant. Emptiness gives structure meaning. Without the void, the web would not be a web. And without the web, there would be no us.